Okay. Can we look up now? Yep. Yep. Guys, come on, we'll start now. So we're going to have a look at the next topic. The binomial theorem. Okay, so let's get started on this then. Guys, are we ready? Come on, I still hear lots of talk and lots of moving. Come on. Okay, I have all your attention now. Good. So, to get started, some definitions just get started. So this symbol here, this is called factorial. Yeah. So for example, 4 factorial is 4 by 3 by 2 by 1, which is 24. 3 factorial is 3 by 2 by 1, yeah, 6. 2 factorial, yeah. 1 factorial, and then 0 factorial. Losers. It's 1. Yeah. So 0 factorial is a bit strange. It's equal to 1. Now, the reason I'm doing factorial is because now I want to define this function. It's written like this. Sometimes people write it like this, and in fact, even sometimes people write it like this. It all means the same thing. So for example, here it would be n factorial over r factorial, n minus r factorial. So for example, 4c2 is 4 factorial over 2 factorial, 4 minus 2 factorial. Yeah. So that's 4, 3, 2, 1, 2, 1. 4 minus 2 is 2. 2 factorial is 2, 1. Cancel. 6. Yeah.
What is the logic behind the factorial?
It's quite complicated, but I'll give you a very, very simplified reason. Okay? I'll just in a second. I'll just scroll over. Yeah? Continue. Oh, by the way, who did I have this morning at 9 o'clock? It was HS1, was it? HS2. So HS2, in HS1's tutorial, I did a question with the P and the Q. The one you were remarking on was quite difficult, wasn't it? So if you want to see it, I did 5A, if you want to watch that part of the video then. 6A. Or 6A, the first one, yeah.
I think we still have the minutes on. Yeah.
Oh, okay. Oh, but I'm sure you'll find it in the video. Anyways, can I scroll to the side now? Yeah? Yeah. Oh yeah, so it's just, let's see, 12 over 2 in total, yeah. Okay, can I scroll to the side? Yeah? Yeah? Okay, so you were asking why on earth is 0 factorial 1. So I'll give you an example here. I have a bookshelf and I have 3 books on it, A, B, and C. How many ways can I rearrange the books? The answer is 6 ways. ABC, ACB, BAC, BCA, yeah, CAB, CBA. So there's 6. Okay. I have 2 books. How many ways can I arrange them? 2. AB or BA? How many arrangements can the shelf be in if there's one book? One. How many arrangements can the shelf be in if there's no books? One. So this is 3 factorial, 2 factorial, 1 factorial, 0 factorial. So yeah, it's like there is one no arrangement is the way I think about it. Okay, so what I want you to do is have a look at your calculator, because your calculator should have this button on it. Yeah? If I open mine here. Did you found on your calculator? Yeah. So once you found that button, I want you to type in 4C2 just to check that you get 6. Yeah. You find it? Yeah. Yeah, guys, look, it's on my calculator. It's here. So I would type 4 Shift C2, and I should get 6. Yeah. Now, what I want you to do next for me, using your calculator, I want you to calculate the following, okay? I want you to calculate 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. So write down those 6 numbers, please. 1, 2, 3, 4, 5, 6. Got that? Got that? Yeah. So the first one, 1. And then here I hope you got 5. And what's the next one? 10, 5, and 1. Now these numbers should look familiar. Pascal's trying 5th row. So this gives us a very useful ability to calculate row coefficients without the need of the triangle. So this is making use of something called the Binomial Theorem, which basically says if you want to calculate x plus y power n, that would be nc0 xn plus nc1 xn minus 1 y plus nc2 xn minus 2 y squared, and so on. So for example here, if I wanted x plus y power 5, that would be 5c0 x5 plus 5c1 x4y plus 5c2 x cubed y squared plus 5c3 x squared y cubed plus 5c4 xy4 plus 5c5y5. Yeah, which would be x5 plus 5x4y plus 10 x cubed y squared plus 10 x squared y cubed plus 5x, xy4, sorry, plus y5. So this is called the binomial theorem. It's more useful than Pascal because you don't have to draw the triangle. So with this theorem you could easily jump to power 100, something like that. Okay, so let's see how useful this theorem is by doing some examples. So basically I did a simple question of expanding, but now let's look at something a bit more interesting now. So that's a very simple example there, x plus y power 5. Okay, can I scroll down? I see people writing still actually. Got that?
Why did you put the 5 behind the x for some of them, but not all of them? Oh, that's the 1, 5, okay.
Yeah. Okay, scroll down. No? Okay. How about this much? Yeah, okay. So, here is another example. What is the x squared coefficient in 2 minus 3x power 4? Now, this is interesting because I'm not asking you to fully expand it. I'm not. I'm only asking you for one term in the expansion. Precisely, I'm asking you what is the number that goes in front of the x squared when you expand. Yeah, so we need to figure it out. So we know that there has to be a c. Yeah? So we know that there has to be a 4c. Now we'll figure out the other number in a minute. And we know that the first one here should be a 2. And the second one should be a minus 3. Now, if we start thinking about this backwards, because we're looking at x squared, it means the minus 3 has to have the same power as the x, because it's with the x, and we want the x to be squared. So the minus 3 gets a 2. That automatically means that this guy down here is a 2, because you notice that the number down below matches the power. So 2 with 2, 3 with 3, 4 with 4. So that still leaves us with to figure out the power that goes on the 2. And the last thing we notice is that the total power here, it must make 4. So, you know, if I was to jump to say this one here, here's 5, and here what powers have we got? 3 and 2. Or if I go here, here's 5, what powers have I got? 1 and 4. Yeah. So if this is a 4 and this is a 2, then I'm forced to pick 2 here. What is 4c2? We had that one earlier, didn't we? 6. And 2 squared is 4. 6 times 4 is 24. 24 times 9 is 216 x squared. So the answer is 216. That's the coefficient of x squared. I was able to jump directly to the term I needed without having to expand fully. This is why it's useful. Yeah, write this one down now.
What's the time of this?
That one is at 14 minutes. Of this one? Yep. Easier, the same, or harder?
Harder.
Well, I know what your class wants. What do you want? Same one, okay. So, let's say I want the x cubed coefficient in minus x plus 1 power 5, as an example. Okay, so, scroll down here a bit. We have a c with a number, a term minus x, a term 1. Let's start filling in, because this needs a power and this needs a power. Okay. I know this one here must be what? 5. Because of this. I know this one here must be what? 3. Because this is what I want. Therefore, I know this one here, 2. Now, what do I put here, 3 or 2? Either. Because 5c3 and 5c2 are the same. So I'll just put 3. Doesn't matter. 5c3 is what? What's 5c3? 10. Minus 1 cubed? Minus 1. And 1 squared? 1. So the coefficient is minus 10.
Well, I don't understand. I understand how each number goes squared, but like C3 or any different.
You can choose 3 or 2.
So I can just put the power of the x to the power of basic.
Either power.
So,
Yeah. Which part? The 5c3. Why the 3? You can use any power. Would you prefer 2?
5c3 and 5c2 is the same.
Yeah. You can use 3 or 2. My point is earlier that you notice that the number down below matches one of the powers always. So like here, this 3 matched that 3. You know, and you might be concerned. You might say, well, which power do I match? Do I match the first one or the second one? Well, it doesn't matter, because 5c3 and 5c2 and 5c2 are the same number. They're both 10.
always the case?
Yeah, and the reason for that is because in Pascal's triangle, you remember it's symmetric, and it's the reason it doesn't matter, because of the symmetry.
So we could just put the power wherever we want, and it's fine.
So,
You could choose any power.
Yeah.
so whichever
No.
power you know.
Yeah. If you knew 5c2, you could have used that if you knew it already. Is okay?
So if the power is 4 and 1, you can use 4 or 1.
Yeah. No difference whatsoever. Yeah. Is that okay? What's wrong?
Okay, I think this might be the same question, or it
Yeah.
might be different.
Yeah. It's probably the same, but go on.
It's probably
Yeah.
the same. So we could, like, swap between the 2 and the 3, and it'd be fine?
Now, swap what exactly? Are you saying swap the 2 and the 3 up here?
Yeah.
Or put a 2 and a 3 down here?
No.
Up the top? You
Yeah.
can't swap them. Yeah.
Okay, but
Why not? Why can't I do this? 2, 3?
Because you add it for x.
Yeah, because I asked for the x cubed coefficient, not the x squared coefficient. So I need to make the x have a cube. I need it. Yeah? Okay, is that okay now? Yeah? So we go on to the next example. So, expand one plus x power 10. But we don't really want, I don't want you to do all the way up to 10. So my question is expand up to the third term. And I'd like it to be descending. So what that means is I don't want you to fully expand. I just want you to give me the first 3 terms. And I want it descending. Meaning I want you to start at x power 10. Okay? So let's figure this out. So the first one will be a 10C0, a 1 and an X. The next one will be a 10C1, a 1 and an X. The next one will be a 10C2, a 1 and an X. And then I don't care after that, because I only wanted the first three. But I certainly care about the power, because I want my powers descending. So should I start this one, the 1, with a 10 or a 0?
0.
Yeah, because I want my X to have a 10, so that the next time it has a 9 and an 8. And this is a 1 and a 2. So this is X10 plus 10X9. What is 10C2 now? What is it? 45X8, etc. So I ask for the first three terms descending. There they are. Yeah?
Oh, that's why we're starting with 0 descendants.
Yeah, because of the descendant. Yeah.
If it was, for example, 1 plus y to the power 10, and then we would put 10, 0, and so then, no,
It would be the same. Yeah. Go ahead.
no, yeah, confusing.
Yeah.
I have two.
Yeah.
Okay, one of them, I think it might be really similar.
Yeah.
What if we have two variables, or more than one variable?
Yeah, I have to specify which one to descend in. So like if it was say X plus Y, I would have to say descend in X or descend in Y. Yeah.
Okay.
Yeah. That's what you were trying to get to, was it? Yeah.
Okay. Second
Yeah.
thing would be, going back to the previous question.
Yeah.
I'm sorry. When it says, let's say they say the coefficient of x3.
Yeah.
You gave us the x with the power of 1, but what was not the power of 1.
What do you mean? In the last one?
Yeah, for example.
Well, no, this X has a cubed.
No. The x within the first, within the question.
Within the
x3 coefficient and
Oh, here.
Yeah. Then what do we do?
Oh, if the X,
Yeah.
if the X had something on it, or
Yeah.
like.
Like a 2 word.
Yeah, okay. No, I'll do a question like that because that. When I asked earlier if you wanted a harder one, that's something that would be harder.
You multiply the powers.
Yeah, but you need to think carefully about. It's a little bit more thinking, but yeah, let's do something like that. I'll just do a quick enough one. So let's say I want the coefficient of let's again say x squared in I don't know. No, let's make it more interesting. Let's say x6 in the expression x squared plus 2x squared plus 3 power, I don't know, power 10. Okay, so I know that I'll have a number, a c, a number, a 2x squared number, and a 3 number. Let's fill in the numbers we can easily fill in first. So this one here has to be a 10. That's fine. Now, we need to think carefully about what we put here. It has to be a 3, because 2 squared cubed makes x6. And if that's a 3, then this one here has to be a 7, and this one here has to be a 3. So you have 10c3.
Does it have to be a 3? It can be a 7 too.
Which one?
So 10 combination.
Oh yeah, it could be. Yeah, it could be a 7. Yeah. It has to be a 3 or it has to be a 7. 2 cubed 3, 7, x6. So that's your coefficient there. In this case. Yeah.
Yeah. I get
Yeah.
that. What I was trying to get to is that if it's like, for example, they tell us x5 and they give us like x2 and they tell us to.
I don't think you can get an x5.
Yeah, exactly.
Yeah.
It's not divisible.
Yeah, that's it. So they wouldn't do that, you know. It would have to at least appear. Yeah.
那好的 log definition.
What's it? Log is next chapter.
You see the times are.
Yeah. This all comes up a little later.
Wait. You got 3 and 7 because you want x to the power of 6 and 2 times 3 is 6.
Yeah. Yeah, correct. And I have to use 3 and 7 because I still need to make a 10. Yeah. I don't know if I'm seeing faces of confusion or understanding or sleepiness or all.
All of the above.
All of the above, okay, yeah. Continue? Yep, okay. Right. So, I'm going to give you a harder one to try first before I do it. Because I'd like to see if you can do this now that you understand how the C function works. So, px plus q power 5 equals x5 plus 15x4 plus 90x cubed. No, find p and q. So, find p and q for me. See if you can figure this one out. Looks like it, doesn't it? Yeah. Okay. Should be enough time. Yeah? Good. Yeah, good. So what you do is you expand on the left and you get 5c0 px5 q0, yeah, plus 5c1 px4 q1 plus 5c2 px cubed q squared, etc. Yeah? Now, the left can be simplified into p5 x5 plus 5p4 q x4 plus 10p cubed q squared x cubed dot dot dot. And that should equal your x5 plus your 15x4 plus your 90x cubed. Now, by directly comparing, you can see p power 5 has to be 1, and 5p4q has to be 15, yeah? And 10p cubed q squared is supposed to be 90. So let me just write those statements down. We need p5 to equal 1. We need 5p4q to equal 15. And we need 10p cubed q squared to equal 90. Right, well this obviously can only be p equals 1. If I put that in there, I get 5q equals 15. So q has to be 3. Now, this one I don't need, but I can still check my answer, yeah. So is 10 times 1 cubed times 5 squared equal to 90? 5 squared is... No?
It's 3 squared.
Oh, sorry. 3, not 5, sorry. 3 squared is 9, 9 times 10 is 90. Yeah. So P is 1 and Q is 3. Sometimes you have to think about the signs, you know, because if I said P6 equals 1, what's P? Plus or minus 1, yeah. Huh? I put it into the second one and I got Q. Oh, I'm only comparing coefficients.
So you're comparing P5 x5 to x5.
To the coefficient of x5.
No, what I'm trying to say is P5 x5 to x5, the whole thing to
Oh yeah, so you can cancel the x5s if you think about it
Yeah.
like that, yeah. Okay, write this one down now.
So,
Yeah. This line? This line? Yeah. So are you happy with where I got P5 equals 1? Okay. So the idea is like this. If I had ax cubed plus bx squared plus blah 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 equals, let's say, x cubed plus 10x squared plus blah blah blah. If these are supposed to be the same expression, then the a has to be equal to 1. And the b has to be equal to 10. And the next coefficient needs to equal the next one here. It's a comparison. So, back in my original question, on my right, the x power 5 had a coefficient of 1. Therefore, on the left, the x power 5 must also have a coefficient of 1. So that means my p power 5 has to be and can only be 1 for the left and the right to be equal. While if p5 equals 1, then p has to be 1. Now, by looking at the x4 coefficient, p4q has to be 15. But I know p is 1, so 5q has to be 15, which means q has to be 3. And now I'm finished. I have my p is 1 and my q is 3. And if you want to check the answer, then it should be the case that if I do x plus 3 power, what's it? 5, wasn't it? Was it? Yeah. I'm claiming that p is 1 and q is 3. So therefore x plus 3 power 5 should be, what did I say? x5 plus 15x4 plus 90x cubed. And you can check it and you can expand and you see, oh yeah, no, it is right. P is 1 and q is 3. Because 1x plus 3 power 5 does give me the thing I want. Yeah? Yeah.
In a test, do we have to plug it into the third one just to make sure it's correct?
No, I just put the third one in there for you just to be confident to know that you got the P and the Q right. Now you might have to if there's some issue with the sign, you know, like if the P could have been plus or minus 1. Maybe, but usually it's not necessary. Yeah?
I'm confused how you go with the blue circle at the start. Second one.
P5 equals 1.
Yeah.
Oh, no, I think it's talking about 5 plus P4. You expanded the left.
Which
How
one?
did you come from the first one to this one?
First to the second.
Yeah.
Oh, okay, yeah. So here, I'll wait for you to sit
No,
down.
that's for the first term.
No, you're asking me how do I go from here to here?
Yes.
Yeah. So 5c0 on the calculator is a 1. P power 5 is a P power 5, and Q power 0 is 1. So what you have is 1, P5, X5, and 1, which I just grouped together as P5, X5. 5C1 is 5, P4 is P4, Q1 is Q1, and X4 is X4. So that's my 5P4Q X4. So I'm just doing each bit one by one.
Why did the Q go before the X?
Yeah, the order's not important. It's not important, no.
Oh, yeah.
No. Because of the multiplication. Okay, anything over here? No, it's okay. Yeah. Example, 5a. Yeah, actually, so here, how many unknowns were you looking for? 2, but how many equations could you have made? Could have made 3, okay? So why might you need 3? Well, you might need 3 for a problem like this. if I have px plus q power n, now you need 3.
Yeah,
You need to figure out p, q, and n.
you have to evaluate.
Yep, and that is hard. So, hang on. 1a,
That makes me
1h, sure does. 2a, 2h, 3a, 3h.
Why is there 5A on top?
Hmm?
Why is there
Oh yeah, I'm looking at question 5 here. So 1a, 1h, 2a, 2h, 3a. Now 4, it's optional because it's quite difficult. It's good practice, but it's quite difficult. 4a and 4h and 5a optional. I think it's a good idea to do it, but for exam purposes, you need to have these ones I marked, okay? But if you can do 3h and 5h, it's good. So, can you get a start on those for a few minutes now? You can try those for a few minutes.
So,